Welcome to the Crazy Hat Chemist. So today here's another video on atomic structure and electron configuration. So let's get moving. Bam! Today we're talking about electron configuration and an orbital box diagram for hydrogen. Now you're going to repeat this video because this video is going to give you the basics of what you need to know for all the other future ones. Okay, so this is the basic one. It's a simple one, but you need to know what all these numbers and letters correspond to. So, we're going to write the electron configuration and orbital box diagram for hydrogen. The first thing you need to do is get yourself a periodic table, find out where hydrogen is. It is the first element. That is the atomic number 1. That is a Z of 1. So, I'm going to write out the standard nuclear notation for hydrogen. That is the AXZ format. This 1 is equal to the Z. That's why it's a Z of 1, because that's the atomic number, which is equal to the number of protons, which corresponds to the number of electrons in a neutral element, and this element here is neutral. So, Z equals 1, therefore there is 1 electron in hydrogen. Hopefully that works well for you. The electron configuration, therefore, is the following, and this is read as 1s1. Okay, the 1 in blue there, that is N, that corresponds to the principal quantum number. That's why it's a 1, because it's in period 1, it's closest to the nucleus. Okay, the S corresponds to the L value, which is the angular momentum quantum number, and the orbital type, which in this case it happens to be an S-type orbital. Okay, this electron, this number 1 here, corresponds to the number of electrons in the subshell, in that particular orbital, in this case. So, that is 1 electron. Okay? Hopefully you got that. So, the electron configuration for hydrogen is read as 1s1. Alright, now, we're going to write the orbital box diagram for hydrogen, but first we need to write the electron configuration for hydrogen. So we're going to go back to the standard nuclear notation, that is the AXZ format. Then we're going to write the electron configuration just like we did before, that is the 1s1. Okay, and we are going to have a single box. That single box represents an orbital, just a single orbital. Okay, so how many boxes or orbitals do you draw? They correspond to the number of m sub L values, and m sub L in this case is 2L plus 1. Okay, so that would be 0 for the S-type orbital because it's an L of 0, so it's 0 times 2 plus 1 equals 1, therefore 1 box. Now we need to label that box. That box is going to be a 1S-type box. Notice that I didn't have 1S1, it's just 1S. Okay, that 1 in the orangey color there is going to be corresponding to an electron, and electrons are drawn as arrows. Okay, that 1 is the principal quantum number, just like it was before. The S is the angular momentum quantum number. That's an L of 0. It's an S-type orbital. That's the angular momentum quantum number. Now I'm going to have 1 arrow, and that 1 arrow is up. That is an m sub S value of plus 1/2. That is the spin of the electron. That is a clockwise spin of the electron. Okay, so the value of is positive because the arrow is upward facing, and therefore the spin is clockwise. So here's a really easy way to remember it. Okay, it's a positive 1/2 because if the arrow is up, it's facing towards what? Heaven, and that is positive. If the arrow is facing down, that would be facing towards hell, and that would be negative, and that's why it would be a negative 1/2 for m sub S value if the arrow were down. However, in this case, the arrow is facing up, and therefore it's a positive 1/2 spin. Okay, that is the electron configuration, 1s1, and the orbital box diagram for hydrogen. That is the 1s underneath that single box, not with the dotted circle around it, and then the single arrow that's facing upwards, because there's only 1 electron in hydrogen. Okay, hopefully that made sense for you. And here's another crazy hat. Well, I'm not sure. It's kind of a hat and hair combined together. Okay, I got this from one of my former students, so thank you very much. I really appreciate it. Give me a thumbs up if you like that video. Please subscribe to my YouTube channel. I would appreciate that, and look forward to some more cool chemistry videos. See you next time. Bye now.